right, let's call Steve. Hey. All right.
How's it going?
Your light is very bright behind you.
Yeah, I don't know what to do about that. I was just messing with the camera, and on my camera app it looks fine, and on Skype it looks like all washed out.
Very washed out. I'm going to share my screen back to Steve. Yes, this hat was the Xamarin University hat from Build. The folks that are asking about that. Let's see here. I'm going to... Oh, there you go. That's much better.
Skype maybe is thinking about fixing it. All right.
Fantastic. Let's slide over to here. And we should... That's not you. That's Sarah still. Hang on. Let's go.
It says it's me.
It says it's you, but it's not. We need to change Windows. There it is. There's Steve. Good morning. Good afternoon. Gosh, it's lunchtime now. I thought I downloaded a theme song to play for you. Where'd it go?
Oh, really? I got a theme song?
I downloaded a theme song. How's this one work? Is that a good one?
Not hearing it.
Not hearing it? I'm not sharing it over the sound down. The pipe. Let's do that. Share system sound. There we go. No? Yeah. Too much?
I hear it. Sounds good.
Is that too much of a theme song? No.
What's it from?
It's the wrestler Goldberg with a little ominous intro. I thought it worked.
Nice. All right.
Okay, fine. Do you want to give the quick intro of yourself?
Oh, sure. My name's Steve Smith. Online I go by Ardalis because, shockingly, variations of Steve Smith aren't usually available.
Who knew?
So you'll find me on Twitter, GitHub, ardalis.com. I do training and mentoring for teams that want to write better software and write courses for Pluralsight. I've got about 9 different courses up there. I've got a course on ASP.NET Core on DevIQ as well. And today I think we're going to be talking about static methods and extension methods.
Very cool. I got to switch hats here. Give me 1 second. All right, switching over to the Microsoft hat.
So it's fair to say you wear a lot of hats in your role at Microsoft now.
Yes, I do. All right, let's switch over to our code. So you've already shared some code with us. I've got it here in Visual Studio Live Share, all connected up. No, Justin, the intro doesn't need more Goldberg. We're good. That was enough for now. All right. So, we're going to talk about static methods, extension methods. These are features that were added to allow us to, extend and modify objects.
That's right. And we should probably just start with static. Like, what is a static class? I'm assuming we haven't covered that yet today.
No, we haven't.
All right. So there's static classes, and then there's also static methods. And any class can have a static method. But a static class has to have all static methods, so it's a way to enforce that. And I think, I'm not sure in here if I created one that was a class that just had a static method, but you can add a static method to anything. So for instance, in this example, I could just have a public static void, do something, and it would be whatever. And then anything can call this without having to have an instance of it. So I can just call do something, and now that's valid C# code.
Cool.
Usually in an object-oriented language, you want to use objects. You want to use class instances, especially for anything that has state, and typically for anything that has a dependency on some kind of infrastructure or some kind of external thing. Like if you're writing to a file or talking to a database, you generally want to avoid using statics for that kind of thing. Because it makes your code very tightly coupled to whatever it is that static is doing.
Okay. And because C# is, it's a managed language, it'll manage all the memory for us, we want to be able to clean up those resources automatically afterwards. That static method doesn't give us a good way to have a cleanup method hanging out there to dispose and clean up those things afterwards.
That's true. If you are going to do something with resources like that, you'd want to put whatever cleanup code inside that static method. So you know, set up and then do the work and then make sure you cleaned it up, all within that space generally. For me, the larger problem is I like to do a lot of test-driven code, and in my experience, having a lot of automated tests for your code is one of the best ways to ensure that it remains relatively bug-free and relatively easy to extend and change in the future. And static methods that have side effects tend to make it very difficult to write those kinds of tests. So, for example, let's get rid of this class for a second, or this method. And you can see what I'm doing on your screen, right?
Oh, yeah, we can see everything. But before you show that next sample, Userman is asking, wonder what .NET version will add extension properties. I tell you what, Userman, Mads Torgerson will be joining us in a couple hours. You can ask him then.
He would be the one to ask.
So Mads is the lead language designer for C#. All right. So
let me jump over to this student class that I created for a moment, and just imagine that it has a public static void log method, and in here, I don't know why you would put this on a student, but in here maybe it opens up a file and logs info to it, right? Typical. I want to log a string or log some data to this method. Maybe it takes a string message, and then in addition, maybe this this class also has something like public is good student, and this will return something like should probably be a Boolean. This will return something like if their classes are all passing. So we'll look at how that works in a minute, but I could do something very simple like say return completed courses dot all such C each course such that we'll pull in link here for a moment. We'll talk more about link in just a second. Courses. And I'm hitting Control Dot in Visual Studio 2017. It also works in Visual Studio Code, and that's letting me access that little light bulb icon without having to use my mouse. So, and we'll say C dot grade received dot passing. So we'll say all their courses are passing. You see this is underscored, and I've got a little helper thing saying, hey, I don't know what that is, but that's an extension method, and we'll talk about that in a minute too. All right, so I'm pulling that in. And Jeff, you wanted to say something, it sounds like.
Yeah, so there's a couple questions here in the chat room. This is a big step up from loops and switches. Actually, what Steve's showing us is he's a couple of these methods and then these extension methods, these static methods that we've already seen how to do a method and a static method previously. But we're going to dig into it and we're going to see that we can automate and make some of those loops and loop structures with the predicate method like this all that you're seeing Steve use here. We can simplify some of that and make it very, very terse syntax here. Async Awake asks a good question. Can we upload the project on GitHub so they can code along and check it out in Visual Studio?
That is a good point. It's actually already there.
It is?
Yep. So let me just give you a link to it.
All right.
And let's see, what's the best way to do that? I should probably just put that in the chat.
Yep. You can paste it into the Skype chat, and I can attach that into.
I could put it into Twitch, which I have open.
That's a good idea. Put it into Twitch.
How about that? All right, so here it is. And for folks that are maybe watching this later on, it's also there. So if you're seeing this recorded later.
What I'm going to do is I'm going to copy that, and I will save that into the GitHub repository later as a link for more details.
Great. Okay, so this is a little bit of a tangent just about testing. So I apologize. I'm kind of diving into something before we really covered the topic. But I wanted to make the point that you want to be very careful with static methods that they aren't doing things that have side effects or dependencies outside of your code because they will have this viral effect that makes your code difficult to test. So if I want to write a test for this method right here that says, hey, is this a good student? And I could write a test that says, okay, well, given some student that has good grades, I expect this is going to give me a true. given some student that has bad grades, it'll give me a false.
Mm.
So now when I go to write this test, because it has this log method, and in here we could imagine that this is going to say, file dot open some path here, C colon whatever. If that file doesn't exist and this thing blows up, then all my tests are going to fail because of this line. And so that's something you want to be real careful of. It's very common, especially in legacy code, that I see for these types of static methods to exist that talk to a database, talk to the file system, whatever it might be, and they tend to make all the code that uses them very difficult to test. So just be very careful of that. All right, so let's step back from that for a moment and talk more about what static methods are, and see if are there any questions. Extension methods are great. All right, cool. Normally when you have a class, like this class student, it has methods that are instance methods. So you can only get to those methods from some other class if you have an instance of that class. So I have to new up a student before I could call any methods or access its properties. Like this isGoodStudent method, I can only reference that if I have a student. And when I do, it's going to be referencing that student's state. Right? So it'll have that student's first name, that student's last name. A static method is something that's defined on the class itself. And so you can access it just by referencing the class. And this can be very useful for things that are more general for that. A very common approach is if you've got utility methods that can work for anything of that type. If you look at the string class, you'll see there's all kinds of utility methods off of string.
Oh, yeah.
So I can say string dot, and I have all these different things here.
Actually, I can't see your IntelliSense from this side. I'll do a control. I'll do a control space here so we can see all those different methods. Yeah.
All right, I don't see it on your screen either, but okay, there it is. Good. So you can see there's a bunch of different things that are static methods that are off of string, and then if you have an actual string, you also have access to methods. So it has both instance methods and static methods.
Okay. That kind of makes sense. There's things that I can do with an instance of this object, and there's things that I can do to help modify and interact with that. Gosh, no, that's not it. With a static method, there's things that I can do on just that type of method. No.
You can think of the static method as just being a simple function, and in C#, since it's not a functional language, we can't have functions that are just hanging out there, right? So we have to put it somewhere. So we put that function on some type, some class instance, so that we can reference it by saying, whatever dot that method. In other more functional languages, you could just create a function and it just lives, in the global namespace. C# doesn't allow you to do that. So all those string extension methods, it's nice that they're on string, but they could have been on any other type and done exactly the same thing. They don't have any dependency on the state of a string or on stringness. It's just an organizational function that we use, that we decide to put that function on string because those are things that are related to strings.
Would you agree with what Nimi is saying here in the chat room, that every method that could be static should be static?
You will see that as a guidance from static analysis tools. So if you're running ReSharper or other static analysis tools, and you have some method like on your class where it's taking in things that aren't instance properties, let's say, it'll often tell you, hey, this method can be made static. And frequently that's a good call. In fact, one of the things it does if you make that static is it can inform other developers that this is just a utility method and it doesn't reference instance state for this class. Because if it did, it wouldn't be possible for it to be a static method.
Gotcha. Okay.
And that's maybe worth showing. So if I create a static method here, like public void or public static void do something in here, and then I say if this dot first name or something like that, it's going to tell me, first of all, I can't access this. Probably, and second of all, what does it tell me here? The name can be simplified. What does that mean?
Right. If I mouse over, name could be simplified. It doesn't know what
it doesn't
is.
like this thing, but here it's telling me, and you can't see it on your screen. But I got rid of there it goes. I got rid of the this, and now it says an object reference is required for the non-static field method or property student.firstname. So I can't just refer to my property, even though this method is on this student class. I can't access its properties because they're not static. Now it is possible to have static properties, but in this case I don't. So
I think you've got some party crashers there behind you.
I'm ignoring them. All right, hang on one sec.
Who's there? Oh, here it comes.
Hey, how's it going?
Yeah, I got Brendan and Sarah hanging out here, but I locked the door so they don't have any access. All I can do is knock.
There you go. What is a nice starting project in C#?
What was the question?
So the question here is, what is a nice starting project in C#? Gosh, our Canny Aster. There's all kinds of simple starting projects. Console projects are pretty easy to get started with because you're really only working with interacting with the command line, right? You're not thinking about all the different things with controls and widgets you might be painting on screen. But there are some ASP.NET, some website projects that when you start with just the base template, you're going to get a lot of features quickly that might be overwhelming. So I like to tell folks, check out a console first, and then we can get into ASP.NET a little bit later. And we're actually going to do that a little bit later today. All right. Oh, do I see some of our friends? There's Calum. There's, that's Glenn Condren from the ASP.NET team. How long have we been going? 2:20. So, now we're saying let them in. Okay. Here they come. This is ASP.NET is a console app. Oh, don't confuse the new folks.
All right, I opened the door. I don't know if they're going to come back.
All right.
All right, so let me get back into statics, and let's talk about extension methods, which are a special case of statics.
Yeah.
And they can be pretty useful. So I switched over to this other file. Uh-oh, here they come.
It's the fun of live internet streams. There's Brendan. Hello. Yes, crashing my stream. There's Sinclair Nader in the chat room. Hello, and then now Sarah's over at Steve's place.
What's up?
Where is that camera?
It's right there.
Oh, there.
So we're over there. Yeah.
Hello.
Hi guys.
So
How's it going, Fritz?
We're
it going,
doing
stream?
the Ohio crowd here.
yes. All of
Hey, I
Ohio
see
is
Dr.
in one
Blue.
room.
And SP Boyer. And
Is J.R. Gifford still over there? And
yeah.
Stream bombers. Nice.
Async Awake
Yeah.
is in there too.
Stream
I
snipers.
mean, keep in mind, I got to her part of the stream like minutes after it ended.
yeah, the doorbell that they heard on stream
Yeah, that was
actually
me.
who
Hi.
at my door.
Yeah.
There you go.
It's pretty
You're
good.
just rolling up through Stowe and into Hudson.
Exactly.
Yeah.
There
Nice.
you go.
Yeah.
West Virginia's in the house now. All right. There's Sinclair Nader.
Have fun.
See you guys.
Bye, everybody.
See you guys.
Yes, that was a IRL in real life raid. All right. So Streamception, absolutely. So there's your fun.
All right. I let him in. It was fine. Okay, so in this example, I'm
Extension
using
methods, yes.
tests to show off all these different things. So do you have live unit testing? Could you run that
I
maybe?
Do. So I'm going to go to test up here, and I will choose live unit testing and start. So this is a feature of Visual Studio Enterprise Edition, and it should start them here. Thank you to all of our new followers today. You can see it just over my shoulder there. It's building here. It's doing stuff in the background to get the test running. And we should see it appear in just a second here. Come on. Right, tests, is it?
Works on my machine.
Let's see. What's that follower GIF from? That's Steve Ballmer at a internal Microsoft event talking about how important developers are. And I like to use that as a greeting for all of our new followers that join us here. Yes, works on my machine. I know. It looks like it wants to run.
All right. Well, we'll leave that
Actually,
aside.
no, look, Test Explorer is starting to fill up here. It's starting to
Yeah,
give me details.
They're all green on mine.
Of course they are. No, this isn't MS Test. This is actually, so what you see with these fact items here that you see on line 20 and line 10, those are what are called attributes. And we use those to decorate methods or classes to modify and enhance them with some information that the compiler will use at runtime, at build time to enhance them, right? So fact is actually a feature of the XUnit framework to indicate that this is a test here, and that what's happening in here is a fact. This should be true. Nimi says, I think Test Explorer will only work if you open the solution. That would be a pain. Let me see if I can just click run all here and get the test to run. No, it's not passing through the test to me.
Okay. Yeah, I mean, there's only one project and the tests are in it, so
Yeah.
but it's fine. Just trust that they work. All right. So the thing we want to talk about here with extension methods is that you can take some type that doesn't already have a method, and you can add that method to it. And it doesn't actually become an instance method on that type, but it looks like an instance method for most purposes. So if we look at this highlighted code here, we have sample string.wordCount. Word count is not an actual string method. And you can see right here that sample string is of type string. But I was able to extend the functionality of strings in my code by creating this extension method. We can go ahead.
Right. So this isn't something that comes out of the box. You're adding on, you're spot welding it onto the string object.
Exactly. And so you can add anything you want to any existing classes that are out there. It's pretty handy. In this case, word count, it's going to see that sentence right there, and it's going to use some logic to figure out how many words there are. And in my test, you can see I'm asserting that there are 9 words in that string. If you, Jeff, on your side, want to mouse over that word count method, it should tell you in the editor that that is an extension method. So it gives you a hint that that's not really a string method, but it's an extension method.
And it's coming from somewhere else.
Right.
All right.
And now the only reason that that extension method is showing up for me is because I'm using its namespace. So at the top on line 2, you can see that I've pulled in a few different namespaces. One of them is my string extensions. And so let's go look at that. We could right-click on word count and say go to definition, or we can just open up the string extensions class, which I'll go ahead and do now. And you should see on your screen, I think.
Oh, yeah, I've got it.
You have to navigate there separately? Okay. So here is an example of an extension method, and there's a few rules for extension methods that I've got here in the comments. The first one on line 7 is that they must be defined in a static class. So you can't put an extension method just anywhere. You can't add it to a class that you're already using as an instance class. They have to go inside of a static class. And a convention that's frequently used is to put them in a type extensions class. So this one I would probably, if I were doing this for real, I'd probably call it string extensions here. And then the other thing is the extension method itself has to be static. And there's a special rule. This is the one bit of syntax you have to remember to make an extension method work, is that the parameter that you're using has to have this keyword or modifier in front of it. And that's what makes it an extension method. If I got rid of that keyword, it wouldn't act as an extension to string anymore. It would just be a method that I could call.
Yeah, I like to think of this statement as you're telling it, put this method on this object, right? And it's this object I'm putting it on is the string.
Exactly. That's right. So because I have this syntax now, that's what makes it so this word count will appear. Now it only appears, obviously, if I have that namespace. So I don't see every extension method that anyone ever in the universe has created for strings. I only see, the ones that I have the namespaces pulled in for. And in fact, I could have a bunch of different extensions for strings in different namespaces for different purposes, and they won't show up unless I pull in that namespace. Now, if I get the name exactly right, then my tooling will usually help me and say, oh, I see that you wanted to use this thing. I know about it. I have it in this namespace, so I'll offer to give you that using statement. And that happens all the time with common extension method-based frameworks. The one you'll use probably the most frequently in C# is link. So for instance, I don't have link pulled in right here. If I want to use a link method, like here I've got this string. If I make it split into an array with, I don't know, space or whatever the split syntax is. Split, char, separator. That's it. I did that.
Yep. And now we get a little red line there because our types don't match.
Oh, is that what it is? But to pull in link, is that what the red line is there? All right, that's fine. I would just say, let's say that first. And so this here, that first, is a link extension method. And when I say control dot, or I hit this little lightning bulb here, it's going to offer to pull in system.link. And now
here,
that works.
Let me do it from my side so that folks can see the control.
Sure. So I'll delete the namespace, and you go ahead.
Yeah, just so it's easy for folks to see. So I'm going to do control dot, and you see the using system.link, and it's even hinting at you that it's going to put that using statement there. So I'll let that finish, and the red goes away like you saw Steve do just a minute ago. Cool.
All right. So we'll talk more about link in a few minutes. But next, let's look at another thing that you can extend that folks don't necessarily even realize, which is enumerations. Now, I don't know if you've had anyone talk about enums today. I don't think you have.
No, we haven't talked about that.
All right. So enums, if you're not familiar with them, are a very simple type in C#. And so I've created one for grades. And if I go to that definition of grades, you'll find them in grades.cs, wherever that is.
Yep, it's following you around.
All right, cool. And so here's my enum for grades. You can see on line 6, it just assigns them all a value, basically like the US, A through F system with the numbers you would use for a typical GPA. So A is a 4, B is a 3, etc. Now, an enum doesn't typically have any behavior of its own. So frequently it's useful for very simple things where you just want to assign a label to a value. But if you want to start adding behavior to it, a lot of times you'll want to move away from an enum and use something else and actually use a class. But one alternative to that, if you're not quite ready to go that far and you don't want to add a class, is that you can add extensions to an enum. So if we look at my grade extensions in here, I've got a very simple extension method for grades. Is it going to follow me?
Oh, yeah. It's following along.
All right. I'm just watching the stream and seeing it. So I guess there's a little delay. And in here, I've got this public static bool passing that will return true if it's a passing grade, which is just defined as whether or not it's greater than the minimum passing grade, which is a D here. Now, notice again that because it's an extension method, it has to have the this notation on that thing. But this allows us now in this test case that you can see here to assert that a poor student grade, which was an F, is false is passing.
Yeah.
And the other ones, an A or a C or a D as well, would all be passing.
So the enum is just a collection of possible values that you can set. Just like a Boolean is either true or false, you've created an enum called grades that has 5 possible values, and now you've added on to that grades to check whether they're passing grade. That
Correct.
Makes sense.
Yep. Now you can add extension methods to any type. So if you wanted to add something to an integer type, you could easily do that.
Okay.
And so extension methods can be very helpful. One of the ones, like I mentioned, that's built in and is very useful is link. And if you're a C# developer, link is definitely your friend, especially for working with any type of collection data. So I've put together a few examples of how you can use link in this next bit here. So the first one that we can look at is just a simple order by. And so if we look at this method here, I have an array of integers, and you can see it's in a mixed up order, so 10, 45, 15. But I can take that, and instead of having to write my own sorting method or call some sort routine, I can simply use the order by method, which is a link method, and tell it that I want to just order by the number itself, which is what this G such that G means, and then return that back as an array. And so that will give me basically a copy of that first array, but now in a sorted order.
So by including that namespace there on line 4, and this comes with .NET. You don't have to go out and get it from anywhere. That makes this order by and a bunch of other link features available to us, right? So we can act on arrays and other collections. Very cool.
Yeah, exactly. So that's order by. Order by can be used with objects too, not just integers. And so you could order by a property of an object if you wanted to. I don't know if I have an example of that here, but we could code one up real quick if we wanted. So then another one that I use all the time is count. And count is an extension method. Well, it's worth saying that most of these link commands are extensions on the Ienumerable interface. So Ienumerable is a simple interface that pretty much all collections in .NET have, and it simply is applied to any type that you can enumerate over. So that interface has something that will basically let you grab the next item in the list and know whether or not you're at the end of the list.
So just like we saw the for loops with Sarah earlier, right? An enumerable is just something that you can for over, and behind the scenes, it's kind of doing that.
Right.
Kinda.
Right. And simple types like arrays are enumerable. Lists are enumerable. Dictionaries, keys and things can be enumerable. Anything you can enumerate is enumerable. And in fact, you can even create infinite enumerable methods if you want. So there's some interesting things you can do with link and number generators, where you could have a method that returns an integer, and every time you ask it for the next one, it just gives you the next integer forever, using yield return, for example. And then you could run link expressions off of that to give you some interesting ways to code. So order by, if you mouse over it, you'll see it applies to an Ienumerable as an extension method, and so does count. So looking at this count method here, I can take student data and call count as an extension method using link, and it will just give me, by default, it will give me the count.
I lost you. Oh, there you are, down there. Okay. Right, so if I mouse over count, you can see it's an extension method on Ienumerable of type student, right? That's what that angle bracket is. It's a type of student. Okay.
Right. Yes. So it's using another feature that I don't know that we've covered yet, called generics.
No, we didn't cover generics.
Okay. All that means is that Ienumerable is of a particular type, in this case student, and it's strongly typed, right? So we can treat it as it really is that student. We don't have to cast it from an object or some unknown type into our type. We know at compile time that it really is a student. And that's very helpful in C#. Generics is one of the nicer features that was added way back in C#, I think version 2, if I remember correctly. So here we see that there's some student data, and I'll look at that in just a second. And when we do a count on it, we get the total number of students. So let's jump down and look at what our data is here for a moment. So I have down at the very bottom of this class, I've got a simple method called Populate Data, and it adds 2 students to a list of students. There's one for me, there's one for somebody named Bob Jones, and they have a bunch of classes with some different grades. And I'm using that just as sample data that we can use to run some link expressions against.
Okay.
If you look at them, you can see that I have 3 courses that I've completed, and Bob has 4. And he has a variety of grades, and I have just A's because I get to make this up, so why not? All right, so next, if we look at count isn't something that you can just pass as an empty method. You can also pass an expression to it. So this next one is called count with filter, and we can pass in a Lambda expression to this. And what a Lambda expression is, have we talked about that yet?
No.
No. So we're hitting a lot of topics in this one.
Absolutely.
A Lambda expression is a small little function that performs some work and returns some value. And in this case, I have this small little function that takes in a student, and that's what S is. So I have a function that takes in as a parameter a student of named S, and it returns a Boolean. And that's defined by what you see if you mouse over count on your end, so they'll see the IntelliSense.
Oh yeah.
You'll
So it's
see
got
that
this, yeah,
it says
system
there's a
func.
func, right, of student comma bool. The first thing in that list is the input type, and the last thing in that list is the return type. So in this case, I don't have to explicitly say to return something that's just implied, but I'm basically saying, hey, I have this function, return that first name equals Steve. And so if it does equal Steve, it's going to be true. If it doesn't equal Steve, it's going to be false. And so what count is doing is it's going to iterate over every student in my list, and it's going to count the ones where this is true. And so we expect that this is going to have a count of 1. And you can see on the next line that I'm asserting, there's one student named Steve.
Right. So each one of these instances of this little method that you wrote here, the little func, that S is right. That's the student it's passing in. You see, IntelliSense is helping me there, saying this is a student, and you're performing this test to return a Boolean to decide whether to count that. Makes sense.
Exactly. Yep. And so if I wanted to write this without doing a link expression, let me show you why this is so nice. I would have to do something like int count equals 0 for each var s in student data if s dot first name equals Steve and count increments, right? And then when I'm all done, I would have the total students, right? So
yeah, that's a lot of code to write.
I'd write all this would do the same thing as that one line.
Yeah. There's a question in the chat room. None of the speakers so far is using the var keyword. Is that a discouragement or just for teaching?
Pretty much in my case, just for teaching. I use var very frequently otherwise, but I want to make it very clear to folks that are new what the types are that we're dealing with in a lot of these cases.
Sure. Aspiring DevOps guru. Yeah, that simplification, right, from that for each to just a simple extension method there makes life so much easier. And I accidentally navigated away. My bad. There we go.
Nope. And you're not running the tests, but I am, so I'm just verifying here on my end that I'm not fat fingering any of this. So the test still passes when I assert that my count variable here is 1, just like total students was 1. So it is in fact the same.
Good. That makes sense.
Right. In fact, I'll leave that there so it's in the GitHub repo when I do a commit.
Cool.
A couple other handy link expressions, and there's a lot of them, so obviously we're not going to go through all of link in this quick little intro. But first and last are nice. So I have that collection, and it has a first item and a last item in it, just in the order in which I added them. So I added Steve first, so the first student is going to be Steve, and we call that with just dot first. And the last student is going to be Bob, so last student will be Bob. Now, first and last will blow up if you don't have an element in the collection or if it doesn't match. So let's look at the next one here, where we have the first student named Bob. Again, I can pass in an expression to restrict that collection down to a subset. In this case, all the students whose first name is Bob. And now I know that whole list only has one element in it. But it's also true that the first one is Bob. In this case, the last one would also be Bob. So I could say, var last equals student data dot last, such that s dot first name equal type Bob, right? And that's going to be also true here, where last dot first name is Bob. And do my tests pass? Yes, they do. Now, the thing to be careful about when you're using first and last is that they really don't like it if they don't match anything. So if I have one that says var Jeff equals student data dot first, where your name equals Jeff, it's going to blow up and it's going to tell me sequence contains no elements with an exception.
And actually, Sushinator just asked that question here in the chat room. Shouldn't that be first or default?
Exactly. So my test is no longer passing with this one, and we'll see in the next test what that looks like. So the next test down here is first or default, and it'll scroll down in a second in the Twitch. And so I've got the first Bob student networks like we just saw. If we're looking for a student named Michelle and there isn't one, so I'm looking for first name equal Michelle, that's going to give me null. And I can prove that by down here I say assert.null, Michelle, first Michelle student, and it comes back true. The test passes.
Makes sense. So
you'll typically use first or default a lot more than first, in my experience, because you'd rather get back a null that you can check or return than just have an exception and have your method blow up.
Right. We didn't. Oh shoot! I wanted to get into exceptions in that first hour, and we didn't get into those. But you don't want those exceptions, those errors, to be thrown as much as possible. You want to contain those. So
Correct.
having something that we can test against in that exceptional scenario where there isn't a value, is preferred.
Right. Yeah. Exceptions can be helpful, but you want to make sure that you're not raising exceptions, throwing exceptions under non-exceptional cases, and that's sort of like self-defining. But what we mean by that is if it's a normal flow of your program that this might occur, you shouldn't have an exception happen. So if let's say this is, instead of having it hard-coded what the student name is here, imagine that the user is typing in something into a search method trying to look for a student name something. If they just happen to type in a name that doesn't exist, that's a normal operation for that search function, that it would just return no results. The program shouldn't blow up or have an exception that you need to trap or catch somewhere just because they searched for a non-existent student. So what you would rather do in that case is a first or default and just return null, and then somewhere check for that null and let them know, hey, there weren't any matching students.
That makes sense. Agent Mandarin asks a good question. Where would first be a better fit than first or default?
That's a good question. And the answer is, again, where you really want it to be there, right? So if I have some function that just does not work and my program is totally expecting that this will always be there, whatever it might be, this value, maybe it's a configuration setting, right? And I need to get the first item in the configuration setting that has some critical thing that my program needs to run. I might use .first so that when it's not there, it blows up. Now, I probably don't want to just raise that exception that Link is going to throw that's going to say something like sequence contain no elements, because that's not very useful to a developer. So I'll probably catch the Link exception and then wrap it with a better exception that means something to me, like configuration wasn't set up properly or something like that. But that would be a case where it would be okay to have a first instead of a first or default.
I also like to use first when I'm not using some kind of a where clause on this, right? That function to say, filter this and go grab the first of these. If I just want to grab the first on a collection that I know has values, that's when I'll use a first.
Sure. Yep. And if you've already validated that the collection isn't empty, then certainly you can just use first and last at that point and save yourself the trouble.
Yeah. Otherwise, first or default is the safer way to go.
So another link method that's very powerful is select. And what select will let you do, and again, these are all extension methods. They're all static methods that you get as soon as you say using system.link. Select lets you transform data from one thing to another. And folks were saying, hey, you weren't using var. Well, in this case, I have var. And so the only way you'll know what that is if you mouse over it, or if Jeff wants to show that, or if you can just read what the select is doing and kind of see what type that would be. So in this case, student data is a list of students, and when I say .select with that s equal greater than, which I usually read as such that, so I want you to get students such that, and then my return, in this case, it's not a Boolean, it's whatever I want it to be. So I'm going to say it's s.first name plus a blank plus s.last name, and that's going to give me back a string of that name. But I'm not just going to get back one string, right? It's going to do that for every element in my collection. And so what I'm going to get back is an Ienumerable of strings. And so if we look at the type that's coming out of
Look at
that
that.
var,
Yeah.
it's an Ienumerable of string. And then I can assert that it contains Steve Smith and Bob Jones with with the spaces, with the names combined.
Makes sense. So, right, this contains statement is saying, look at this collection and make sure that this value appears inside of it.
That's right, and that's just a method on XUnit's assertion library that I'm using.
Brave Cobra makes a good point here. Select is the map of TypeScript. That's a good way to describe it.
Yes, that's true, exactly. And it's useful in TypeScript and JavaScript to do this type of thing, using map. Select many is another one that you might use. What it does is lets you get access to sub properties of a type, or of elements in a collection rather. So in this case, I've got students, and all students have a collection of completed courses as a property. If I want to get the rolled up list of all the completed courses for all the students, I can do select many, and it will aggregate together the all those collections into one big collection, one big Ienumerable of all those courses. So in this case, the total number of courses between Steve and Bob is 7. And so you can see when I look at the total course count, it's 7 here on this assertion.
Makes sense. I like being able to reach in and touch those inner things and be able to effectively work with that next dependent object in my tree of objects there.
Yes. And then the last one, which folks use very frequently, especially when you're using a tool like Entity Framework, which is going to help you convert your C# code into SQL statements to query a database, is this where extension method. And so I could say, give me all the courses, and that's what this first line does. It's the same one that we used just up there. And then I can further restrict that and say, well, give me all the courses where they don't have a passing grade. And so I can say where not c.gradereceived.passing, and it will give me whatever those are. And if we look down on line 131, you'll see that Bob didn't do so well in calculus. And so in my assertion, we see I'm looking for calculus to be the failed course name, and that passes.
So I look at the where is really, that's my filter. What I just want to take my collection, filter out those, or select just a group of different things. And it sounds weird to say select, but I'm thinking of it more as a database person. That where statement feels just like a where clause that I'd have in a select statement, and I'm returning some collection of values.
Yep, and I'm sure that's where the name came from, right? If you're familiar with SQL, then that you know about where statements to say, give me all the rows of this table where this condition is met, and that's exactly what this is doing for any collection in C#.
Open Window asks, can you apply more conditions in where?
Yes, you can apply them with just an and. So you could say something like and, some other condition. You could say and true, which won't really do anything, but I don't have a lot of other things off of here I could query. I suppose I could do the name, and c.name, course name equals calculus. Right, that's a little bit self-serving, but
that would tell you the folks who had failing calculus grades.
Correct. Another thing you can do is you can chain these together, right? So I could say failed courses. Well, this too is a collection. So then I could have something else that would be like, var failed math courses equals failed courses dot where c such that c dot course name equals calculus. Right, and then that in this case I'm doing it as a whole separate line. But one of the nice things about LINQ is you can chain these together. So I've pulled these apart for clarity, but if I wanted to just get all the math courses, I could say something like var result equals, and you'll see it done like this. We'll say, well, give me the student data, and then on its own line, we might say dot select many s such that s dot completed courses. Now I've got all the courses, and I can say where the grade is not c dot grade received grade. Come on. Here we go. Dot passing. right? And then I could do another where off of this if I wanted to. Like that, and then you can keep doing, you can keep chaining off of this. You can say dot select something, you can say dot count, you can say dot to list, right? That's one of the nice things about these extension methods. They just can keep chaining off of each other here, because every one of them, for the most part, except for count, returns back an Ienumerable that you can again apply another link expression to.
Now, the good follow-up question to, we've chained all this together. At what time does that query get actually executed?
Well, in this case, since we're not talking about like entity framework, this is all going to happen pretty much. These are not iQueryables, right? So,
right.
And I don't think we want to quite get into that right now. So these are all going to run like now. But there's another thing where you could have these expressions have deferred execution, where you're building up an expression tree and not actually running the query until some future point. And that's a cool topic, but not one we can get into in the next couple minutes.
No.
I know there was a question about guard clauses, and I wanted to get back to that before we ran out of time.
Oh, okay.
So let me jump to student real quick and demonstrate here what a guard clause is. So in theory, not a specific library or anything, a guard clause is just a clause that you add at the start of a method that checks that the inputs are good, and if they're not, it immediately throws an exception or returns or whatever, so that the rest of the code can operate believing that the inputs are good. And it's a good way to keep your code simple and avoid a lot of nested indentation, because if you don't use a guard clause for this purpose, but you still want to do the same work, you might end up with something like, well, if first name is not equal null, open curly, and then say, well, if last name is not equal null, open curly, and then finally way in here is where we're going to do your happy path of your actual code that you wanted to do. By using these guard clauses, you eliminate all of that, right? And then maybe over here you'd say like else, throw argument exception here, right? Throw a new argument exception. And then down here you'd have another else, throw argument exception, right? So you don't want to write code like that where you're doing your checks and then you're doing your bad conditions as else's, because your code gets immensely long and it's hard to follow, and there's a lot of plumbing code in there, and the actual work you're doing, which is this happy path, kind of gets obscured by all these checks. So instead, what you can use is this guard clause pattern, and you just put your checks first, and they immediately throw an exception or return. In this case, these are exception based if there's a problem. So this is using a Nougat package called ardalis.guardclauses that I wrote, and you can extend those guard clauses with your own code. So there's a few that are out of the box that come with it, and they use extension methods, which is why I wanted to cover them here. So this guard.against is of type iGuardClause. And so any extension method on iGuardClause will appear here. And there's a few that ship with the package, like null or whitespace that I'm using.
Okay.
But you could also write your own. And so if we go up here and we look at the grade guards, I have a guard clause here called invalid grade that I've written. And it just checks to make sure that if I'm doing something with a grade, it's one of my actual grades, right, A through F, and not some other input that doesn't apply.
Okay, that makes sense. So,
and I use that when I create a course, right? In the constructor for completed course, it takes in that grade. It makes sure that is a valid grade right when you construct it. So there's no way that you would ever have a course with a grade that was 17 instead of 0 through 4.
Yeah. I just want to run down a couple of questions that we have there leading into the guard clauses that you've created there. Ienumerable are not deferred in introduction. They're just a collection of objects that you can step through. And Ienumerables and list are two different things. A list is a collection that you can add items into, but an Ienumerable is a collection. It's a generically defined collection that you can step through, right? So a list you can hop through and randomly access, but the Ienumerable you can only go forward through.
Right.
And you can't actually go backwards. So that's the difference between those. Now, and Steve, you mentioned that this is a Nougat package. Now, we saw earlier how to add references to our project. A Nougat package is just a reference to a package, to something that's been shared on the nougat.org service, much like you've seen probably on NPM or Ruby Gems, those other package types of services. Nougat is what we use here in .NET.
Right. And on my screen, which I realize people can't see, if I right-click on my project and I say Manage Nougat Packages, it'll bring up a dialog that shows me all of the packages that are installed and let me search for and browse ones that are out there on nougat.org. And if you're looking for packages, you can just go to nougat.org and search there as well.
Yep. There's a package manager object here inside of Visual Studio that you can use here to go out and search for packages directly inside of Visual Studio. So guard clauses, I like that approach because it simplifies all of that checking that I need to do at the beginning of a class.
Yeah, and I have a podcast on my podcast, Weekly Dev Tips, that talks about guard clauses too that people could check out. And so we've got like 1 minute left. I got one last sample I want to show, which is this using static keyword.
Yes.
This is new in C#6, so it's not that new anymore. But what this lets you do is pull in all the static methods off of a type and let you access them without having to prefix it. So math is one that's very commonly used. You can say math.square root or math.pi. If you don't want to write math dot every time you reference one of those, you can say using static system.math, like I'm doing on line 3. And now here on line 14, you can see I can just call square root, and it's mapping that to math.square root. If I wanted to do that with my assertions in XUnit, I could just call equal instead of saying assert equal every time. And then, console is another one that's very common. If you're doing a lot of writing to the console and you don't want to have to type console.writeLine every time, you just want to write writeLine, just do a using static system console, and then you can just refer to writeLine.
Makes sense. Nice and concise, those things you're constantly using, and you don't want to keep writing every time. Awesome stuff. Folks really like your weekly dev podcast. Can we put a link to that in the workshop notes so that folks can know how to get over to that? Sign up and start listening. There we go. weeklydevtips.com.
Yeah, I don't know if that was in that pull request I sent you earlier, but we'll make sure it gets into the show notes on the GitHub.
Terrific. All right. That was quick, and we covered a ton there. Thank you so much, Steve. I really appreciate you joining us here today.
You bet.
This was really, really helpful. And yeah, look at that. Listen to the applause. All those folks in the chat room, they're amazing. Yeah, we're 3 hours in at this point. So thanks so much. I'll catch you another time.
All right.
And I'm going to get ready for our next guest.
Bye, everybody.
See ya. All right. And I'm going to go over to here. There we go.